So formally, a very good evening to all. I'm sure you are excited to attend this program as much excitement that I am for doing this program for you. So once again, a good evening to all the principals, teachers, and students who have come to attend this session. This is basically a session to master the tricks and techniques to attempt the case studies. Now, you know that case studies is coming for the first time and we don't have any question bank as such. Everything is new. So this is an honest attempt on my part to make the case studies relevant for you. How are the questions going to come? So first of all, the CBSE has given this format for us that the sample question paper is going to be of 3 hours and 80 marks, right? And it's going to be consisting of 2 parts. The question paper has got 2 parts, A and B, and with internal choices. And now this part A has got 2 sections. The first section is having 16 questions of 1 mark each, which are 1 mark questions, and then internal choices are provided in 5 questions. And today's session is basically about section 2. Okay, that is the case studies. So there'll be 4 questions for you, and each case study will have 5 case-based subparts. So 5 parts will be there, and you need to answer any 4 out of it. And this is all going to be MCQ. So you'll have to anyway work it out if it requires working out. Otherwise, you'll have to see what are the answers, what is the question, and accordingly. And it's like a comprehension. No, you'll have to read through the passage, understand the passage, what are they trying to tell, and then answer the question accordingly. So without wasting much time, let me go to some typical examples on algebra, geometry, trigonometry, stats, mensuration, probability. So all the topics, I'll try to cover all these. So as I said in the beginning, that we are going to have this in 2 parts. So if you are getting logged out in between, please log in with the same password and ID, right? So case study 1, we are going to the first one, that is shadow formation. We are going to do the shadow formation. Now in shadow formation, what happens? Shadow formation, what happens? Depending on the time, there is a shadow being formed. So if there is a tower or a building or whatever is the object, which is going to block the sun's rays, there will be a shadow which is going to be formed on the ground. So with respect to that, you have a lot of questions. So the first question in front of you, engineers, architects, and surveyors use concept of similarity and trigonometry to calculate the height of objects, right? You are aware of this, that trigonometry is a very important part in calculations of heights. You have done applications of trigonometry. So what is this question? The question is saying a tower is casting a shadow 17.3 meters long, and at the same time a vertical stick casts a shadow 1.73 meter long. So question is, what is the height of the tower? So here we need to understand that these 2 triangles are what type of triangles? These type of triangles are similar triangles, right? So how do we know that they are similar triangles? We can say that they are similar because this angle is 90 degrees, isn't it? And this angle is also 90 degrees. Both are vertical. The tower is also vertical. The stick is also vertical. So it's important that it is 90 degrees. And this is represented by the Greek alphabet theta. You're already aware that unknown angles are represented by theta. Not necessarily, but that's a general notation. So we can say that angle of elevation of the sun is a constant. So I can say these 2 angles are equal. So what happens? By the corollary of AA, we can say these 2 triangles are similar. And if the triangles are similar, what happens? The ratio of sides are going to be equal. That means the sides are in proportion. So if I look at 1.73 and 17.3, you find that this base is 10 times this, isn't it? This is 1.73, this is 17.3. So if this is 1, what is going to happen to the height? This is going to be 10 times of that. So that's going to be 10 meter. So the answer here, we will say, is 10 meter. It's an easy question, right? Because based on concept of similarity, the sides will be in proportion. Now let's understand how to find out theta. What will be the angle of elevation? Can anyone tell me what will be this angle of elevation? This is 1 and this is 1.73. So what is this angle of elevation? They're asking us the angle of elevation, that is theta, right? So how do we get this theta? Anyone wants to attempt? If you apply the ratio of EF by DE, that is the opposite side by base, that is the perpendicular by base. So that is actually tan, isn't it? So tan theta will be 1 by 1.73. Tan theta will be 1 by 1.73, right? So if tan theta is 1 by 1.73, 1.73 is actually the approximate value of which root? Can anyone unmute and tell? Any student who is there? 1.73 is root 3, correct. So here you should know that root 3 is root 3. Yes, root 3. So tan theta is 1 by root 3. So what is the value of theta? Theta is going to be 30 degrees, isn't it? So here this is a thing that you have to remember, that root 3 is 1.73. So this is going to be 30. So we've got the theta here. Now triangle ABC is dash to triangle DEF, equal, congruent, similar, or none of these. So we have already proved that the triangles are similar. And what will be the value of DF? Now how do you find the value of DF? How do you find the value of DF? By which property can we find out DF?
By Pythagoras theorem.
You can apply Pythagoras theorem, or you could use sine, because the opposite side and the hypotenuse ratio we can do. So when you are applying Pythagoras, remember, it's easier if you take this value as root 3, right? So if this is root 3 and this is 1, what will happen? This will become root 3 square plus 1 square is equal to df square. So this is going to be 3 plus 1 df square. So 4 is equal to df square. So df value will be root of 4. So we get df as 2. Okay. So don't try to rack your brains by multiplying 1.73 into 1.73 and then do, because then you will waste a lot of time. Okay. Because then you may get 3.999 something. So then you will take the root. Then among these choices, it will not come. Of course, by rounding of 1.99 so on, you will get 2, which is the closest possible answer, right? So this is our first question based on shadows. So a question on shadows can be expected. Now see, there are 4 case study questions. So please remember which are the topics which are most likely to come. One is definitely similarity and application of trigonometry, because all the chapters they will not give definitely. So you will have to concentrate on the topics that I am telling you today. Okay. So now we go to the next one. That is pattern formation. Everywhere we find patterns. All around we find patterns. Everything in the universe is consisting of patterns. You look around in your room where you're sitting, you will have lots of patterns on the grills, your bed sheets, your any handicraft, handloom, even monuments, everything has got patterns. So one question on patterns we can expect. So case study 2 is based on patterns. So patterns are a common phenomena observed in handicraft. The following pattern was observed in Munka fabric painting. So, you know, you are doing a lot of art integration these days, and a lot of fabrics and handlooms you are feeling, right? So this is a question based on painting. Now look at the painting. The painting is consisting of triangles, and you have circles which are touching the 3 sides of the triangle. You know what are these circles called? When the circles are touching the 3 sides of the triangle, these are called incircles. Okay, these circles are called incircles. When the triangle is there and the circle is around these triangle, these are called circumcircles. Now these are incircles. Now here the first question is, what is the length of AP? What is the length of AP? Now they have given some dimensions, that AB is 6. Okay, BC value is 10. So this distance is 10. This distance is 6. And this distance is 8. Question is, what is the value of AP? What is the value of AP? So how do we solve this question? How to find out this length of AP? Now see, this is a combination question of, if you look in the tangents, okay, if you look in the tangents, the chapter, what is the property of a tangent? The tangents drawn from an external point to a circle are equal, isn't it? So AP will be equal to AQ. So if I'm going to assume this as X, this will also be X, isn't it? I hope you know this theorem. Length of tangents are always equal from the same external point. Same way, BP equal to BR. So this is going to be Y. BP equal to BR, right? From here to the point of contact. And this is going to be Z. This is going to be Z. Length of the tangents are equal. So what will happen? We are going to get 3 equations. What are the 3 equations here? It is given to you that AB is 6. So this I've assumed X, this is Y. So what will I get? X plus Y is 6. Here, this is y, this is z. I'll get the second equation, y plus z is 10. Here, this is z and this is x, and AC value is given 8. So I'm going to get z plus x is 8. Now you've got three equations. You're going to add this. What will happen? You will get twice. Here, see this? There are 2x, 2y, and 2z. So 2 times x plus y plus z is equal to 8 plus 6 is 14. 14 plus 10, you will get 24. So what is happening? X plus y plus z is going to be 24 upon 2, that is 12. I hope you understood. We have made three equations and we have added it up. And we are getting an equation x plus y plus z is 12. Now, what is the question? Find out x. Find out x. This is what we have to find out. So y plus z, if you notice, is 10. So what I can do is replace the y plus z with 10. So what will happen? X plus 10 is equal to 12. X is equal to 12 minus 10. So what is x? X will be 2. So we get the answer here. X is 2. That means AP is 2 centimeter. Right? So here our conceptual understanding has to be good. Then only the questions can be solved. So here the length of the tangent AP will be 2. And I suppose they had asked something else, then also the procedure will be same, but the substitution would have been different. Right? Now, next part, CR and CQ are equal. Why are they equal? They are secants, tangents, chords, or segments. CR and CQ are tangents. What is the meaning of a tangent? A tangent is a line drawn from the external point to a circle, touching it exactly at one point, touching it. So this is just touching the circle at one point. So we can say these are what? These are tangents. And what is the radius of the circle? Another very important part. What is the radius of the circle? So here, let me try to So this is our triangle. You're able to see the screen, I suppose. Whiteboard, yeah. If you are having a triangle and you want to find out the radius of the incircle, okay, this is called incircle. So how do we find the radius of the incircle? Now I will tell you a method by which we can find out the radius of the incircle, right? So this is our radius and this is the radius of the incircle. So how do we do this? In triangle AOB, if I want to find out area of the triangle AOB, AOB will be half base into height. So half AB multiplied by the height. Now this is 90, isn't it? Angle between radius and tangent at the point of contact is 90. You know the theorem. So here this is 90. So this is going to be the height. So area of triangle AOB will be half AB into R. Area of triangle BOC, this is BOC, is going to be half BC into R. Area of triangle AOC will be half AC into R. You have a similar question, remember, in circles, the long question in the second exercise, where we find area of the three triangles and add. So when you add these three small triangles, what will you get? You will get the area of the big triangle. What will you get? Area of the big triangle. That is area of triangle ABC. So here, what is common on the right side? Anybody? What is common on the right side? Here.
Radius.
Half into radius is common, correct? So inside the bracket, you will get AB plus BC plus CA. So area of the triangle ABC is equal to half into R. And what is AB plus BC plus CA? The sum of three sides of a triangle is known as the perimeter, isn't it? So perimeter divided by 2. Last year you have done this Heron's formula. So area of triangle is R into perimeter by 2. And what is perimeter by 2? Perimeter by 2 is semi-perimeter. So I can say that area of a triangle is equal to radius into semi-perimeter. So from this, I can get a very important formula that radius of an incircle is equal to area of the triangle divided by the semi-perimeter. So if you remember this formula, then no need of doing all this. Okay, it's important that you learn of this because it's after all, it's an MCQ. You get the marks only for the answer. But if it was a question, you could have derived a relation between the area, semi-perimeter and the radius, right? So this is what is important for us right now. You can note this: radius of an incircle is always equal to the area of a triangle divided by its semi-perimeter. So this is valid for all incircles, okay, provided it touches the circle. Okay, so we come back to our question now. Yes. Yeah, in this now, what do we observe? The question was, what is the radius of the circle? Now I have explained to you that radius is equal to area by semi-perimeter, isn't it? I'm using that, area by semi-perimeter. So what is the area of a triangle? This is 6, this is 8 and 10. Can you tell me what type of triangle is this? What type of triangle is this? Yes?
Right triangle, sir. Right triangle.
Correct, because these are Pythagorean.
Right triangle.
Absolutely, ma'am. So 6, 8 and 10 are Pythagorean triplets, isn't it? Suppose you are not able to understand that 6, 8 and 10 are Pythagorean triplets, which you should be knowing, but in case it misses out, then you also have the option of using Heron's formula to find the area of the triangle, right? Class 9 you did, when 3 sides are given, find the area. So right now, yes?
Triangle.
Yeah, this is a 90-degree because 6 square is 36, 8 square is 64. Screen is visible, right? You're able to see the screen. Yes? Yes, what are you trying to say? So this is 6 and this is 8. 6 square plus 8 square is 10 square. So this is a right angle triangle. So area of the triangle we can do half base into height. So half 6 into 8, right? This is the hypotenuse. So base and height can be 8 and 6, right? And semi-perimeter, you will add all this and divide by 2. 6 plus 8, 14. 14 plus 10, 24. 24 by 2 is 12. Isn't it? Semi-perimeter is half of the perimeter. So 48. 48 by 2 is 24. 24 by 12, answer is 2. So what is happening to the radius of the incircle? That is 2 centimeter. I hope that is clear. In case it is not clear, the recording will be available. You can replay, okay? I'm going little fast so that I can cover maximum cases. So next we go to the third question. Have you heard of this name, Sierpinski triangles? Have you heard of Sierpinski triangles? If not, this is a fractal. Okay, anybody has heard about this mathematician by the name of Sierpinski?
No.
No. Okay, so today we have something interesting for you. This is called a Sierpinski triangle. What is a Sierpinski triangle? It is a fractal. Now, what is the meaning of a fractal? A figure which goes on recurring one after the other, subdivided. So you magnify it or you compress it, the pattern will not change. It's going to be similar. So he was a Polish mathematician from Poland, right? His name was Wacław Sierpinski. So this pattern is used in many art forms today. Okay, this is called a Sierpinski triangle. Now, what is the speciality of the Sierpinski triangle? Let's understand that first, and then we go to the question, right? So just let me know if you're able to hear if you're not able to hear the audio, please let me know.
Hello and welcome to my new video, how to draw a Sierpinski triangle step by step.
Are you able to hear the audio?
The Sierpinski triangle is a
video?
famous fractal. A fractal is a shape that can repeat itself at any scale of magnification or reduction. To draw this triangle, I start by drawing an equilateral triangle, a triangle where each side is of equal length. You could use a ruler for your straight lines, or you could just do it by eye. Next, I draw a dot at the halfway point of each side of this first triangle. I then join these 3 dots together to make a new upside down triangle in the center. Plus, by doing this, I have also made 3 new triangles, 1 in each corner. Next, I find the 3 halfway points to the bottom right triangle and draw 3 dots and then join them to make a new set of triangles. I repeat this process again and again. I move on to repeat this process for every upright triangle that I create. A symmetrical pattern appears as you repeat this process. The triangles get smaller and smaller, or bigger and bigger if you start extending the original triangle that we started with. The Sierpinski triangle was named after a Polish mathematician who described the triangle's mathematical properties in 1915. But the pattern has been used for hundreds of years before that. To create the fractal zoom effect at the start and end of this video, I repeat a zoomed image of my drawing. I think seeing a zoomed video image of this reoccurring pattern gives some indication to its unusual properties. I hope you like this video and subscribe to my channel, and see you next time.
Okay, so you heard that. I hope you were able to hear the audio of the Sierpinski triangle. Yes?
Yes, sir.
Yes, good. So Sierpinski triangle was a triangle which was discovered by the Polish mathematician Sierpinski, and this question is based on that. Actually, it is similar triangles. Okay, so here this is an equilateral triangle. Okay, if you heard that audio, the description will be given. Audio is not going to be given in the exam, but there will be a description. So this is an equilateral triangle, and what are we doing? We are joining the midpoints continuously. We are joining the midpoints. I have stopped here, but you could have gone further, and it goes on further till it's not possible to draw anymore. So here, this is an example of a Sierpinski triangle. Okay. So the first part of the question: how many congruent triangles does ABC have? Now, if you look at triangle ABC, how many congruent triangles? Now, please remember that although congruency is done in class 9. There are some questions in similar triangles chapter where congruency is discussed. So don't neglect congruency, please. So how many congruent triangles are there? The answers are 4, 8, 12 or 16. What do you think? From this figure that is given there, how many congruent triangles are there? 4, 8, 12 or 16? Yes?
12, sir.
12, correct.
16.
Yeah, 12. 12. This is because there is no this is our triangles, no? 1, 2, 3, 4 here, 4 here, and 4 here. These 4, 8, 12 are all congruent triangles. They're all exactly identical. Why? Because they're all going to be equilateral triangles. What will be the ratio of triangle DEF to ABC? What will be the ratio of DEF to the full triangle ABC? Now here,
1/4.
yeah, 1/4, correct. So here, there are two ways of doing it. One is by observation that,
So will you please explain the first question?
yeah, first question was how many congruent triangles are there in this full triangle? So congruent triangles are triangles which are exactly identical to each other in terms of size and shape. So how many triangles do I see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Isn't it? I've got 12 congruent triangles. These are all small triangles, but they're all going to be identical with respect to their size and shape because they're going to be equilateral triangles. Fine. So
Sir,
this is the answer.
what about ADE and DEF?
Sir, separately if we see, yes, at a time, how many congruent triangles are there? That is the meaning of the question. So if you are comparing ADE, DBF and FEC, they are separate. 4 triangles are again congruent to each other. So here, if you notice in the book, how many parallel tangents can be drawn? There is a question in the textbook. How many parallel tangents can be drawn? What was the answer of that, sir? How many parallel tangents can be drawn? The answer is 2, because we are considering at a time. We are not considering there are infinite parallel tangents. If you look at other possibilities. So at a time, we are not considering the bigger triangles to the smaller triangle. We are considering the smaller triangles. Okay. So how many congruent triangles are there? And 4, 8, 12, 16 are giving their respect. They are referring to the smaller triangles. Of course, if you are considering the bigger triangles, question should have been more specific. I agree that if you are considering the smaller triangles or the bigger triangles, so that the description should have mentioned. Of course, here in this case, actually this was all colored by the same color. So I have just colored one only. So therefore the answer is 12. Okay. And what will be the ratio of the triangles DEF to ABC? Somebody has already given me the answer, that is 1/4. This is a theorem which is deleted, but please don't do the proof of the theorem, but the application is important. Ratio of areas of two similar triangles is square of their sides. So DE we know is half of BC, isn't it? By midpoint theorem last year you have done, DE is half of BC. So if I square, take the ratio is 1 by 4, or as sir said, these are 4 triangles which are going to be congruent. So this is going to be 1/4 of the total. So both the concepts are okay. We can do 1 by 4. So what will be the area of DEF? What do you think will be the area of this triangle? 4, 8, 12 or 16? The area of this triangle DEF will be how much? It will be
8 centimeters.
8, correct, because this one small portion is 2. And if I look at this, this also can be divided exactly into 4. So it's going to be 2 plus 2 plus 2 plus 2, or 2 into 4, that's going to be 8. Triangles with the same area are always congruent, always similar, may be congruent, will never be congruent or similar. What do you think is the most appropriate option? Triangles with the same area are always congruent, always similar, may be congruent, will never be congruent or similar.
Always similar.
Yeah,
Always similar?
Always
No?
congruent.
Congruent.
Yes?
Always congruent.
Always congruent.
Congruent, sir. Always congruent.
Or triangles with same area are always congruent? Suppose you are having a right angle triangle and an equilateral triangle. Are they similar? No. But their areas can be same. Their areas can be same. So when we say
Will
always
maybe
congruent,
or
yeah,
will
maybe.
maybe congruent.
May be
Will
congruent. So
maybe congruent and similar.
may be congruent. Yeah. So the answer is not always. The answer is may be congruent. Okay. It is not always congruent because the shape can be different, but area can still be same. So that was one of the properties that you did in class 9. Again, that two triangles which have equal area may be congruent, but two triangles which are congruent will definitely have the same area. That is, the opposite is true, right? So we go to the next one. Okay, so you can watch this. Yeah, 1 second.
Pi r squared gives you the area of a circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle.
Right, so you must have done this in the practical activity also. Division of a circle. Now see, this is integration of our practical also. That practical, sometimes you say that questions cannot be asked. Questions can be asked. Here, what is this? The circle is being divided into 8 parts. So if I divide into infinite parts, it almost resembles a rectangle. Here they have divided into 8 parts because it's difficult to show infinity there at this point of time. So here, by cutting and pasting, I'm sure many of you have done this in your school. So this was divided into 8 equal parts, and what have they done? They have placed 7 parts as it is, 1, 2, 3, 4, 5, 6, 7. And the 8th part they have cut into 2 parts. One they have pasted here and one they have pasted here, almost resembling a rectangle. At the moment, it's not a rectangle because we have divided only 8 parts. If you do it into 16 parts, 32 parts, then more and more the shape will resemble a rectangle. So the questions based on this now, a circle was divided into 8 what? Segments. Okay, we are talking about this circle. Segments, arcs, sectors, or semicircle. So your answer will be obviously sectors. These are called sectors.
Sectors.
Yes. And what will be the breadth of this rectangle? Any guesses? What will be the breadth of this rectangle? What will be the
R,
breadth
sir?
of
Radius?
R? Correct.
Radius.
Because that's going to be
Radius.
the radius, because this part of the sector is actually cut and we are pasting here. So this is going to be the radius. So breadth of the rectangle is actually the radius. And what will be the length of the rectangle? This length
Pi
is
r.
going to be
Diameter.
pi r. It's going to be pi r, not diameter. Why? Because what is the length of the full circle? The circumference of the full circle is 2 pi r. But we are putting only 1, 2, 3. This is 3.5 plus half, 4. Only 4 parts. So 4 parts means it is a semicircle. And what is the length of a semicircle, or the circumference here, the perimeter from here to here? It's going to be 2 pi r divided by 2. So that's going to be pi, 2 pi r, that's going to be pi r. So which option is going to be the correct option? Length of the rectangle is 2 pi r, diameter pi d by 2 or pi d?
Sir, C pi d by 2.
It's C pi d by 2, correct, because the diameter is 2r, isn't it? So they have not given you the direct answer. Diameter by 2 is radius, so pi r.
Oh, pi
So
d by
option
2.
number C. Yes, pi d by 2 will be the answer. And the area of the rectangle will be pi r square, 2 pi r, or pi r square. Area of the
Pi r.
rectangle will be pi r square, because actually you are cutting this and making this. So obviously the rectangle's area will also be this. So this is actually the proof of that area of circle is pi r square, right? Okay, so
Sir,
case
can you
study,
explain third part once again?
which one?
Sir, third part.
Okay, length of the rectangle. So length of the rectangle, if you see, is, see, this part is made up of how many arcs here? 1, 2, 3. This is half and this is half. So isn't it made up of 4 parts of this? Now, when you say 4 parts of this, 1, 2, 3, 4, it is actually a semicircle, isn't it? And we know that full circle's length is 2 pi r. So what will be the length of half circle? Length of half circle will be 2 pi r upon 2. So length is going to be pi r. So pi r means the option pi d by 2 is correct, because diameter by 2 is radius. Diameter by 2 is radius. So pi r, isn't it? So option number C will be the length of the rectangle. I hope it's clear. Okay, so now we'll be just having a break of 5 minutes, then we'll rejoin, okay? And then we'll go to the next set of questions. So I hope this is clear. Somebody had asked this question, why is this pi r? That is clear, or should I repeat it?
Yes, sir, it is clear.
Thank you.